Hey guys, how's everything going? This is JSer. In this video, I'm going to solve number 160 from BFE.dev. It's called implement A to B. Actually, I've already solved 141, which is implement B2A. If you're interested, please search on my channel. There's a video for that. So what it is about? It's actually about the base 64 encoded as a base 64 encoding. The idea is for a binary data. It's not safe to transmit into on the internet because there are some unsafe characters, they're reserved keywords, I guess. So in order to transmit the data, we re-represent the binary data with a selected safe characters, which is this 64 characters, and then transmit them. So when we receive the data, we could decode it again to get the original data. So how this done? Let's retrieve the last submission to see. Okay, so we have this 64 safe character, and then for each character, each character will be representing 8 bits, right? For 1 byte, 8 bits. So 3 is 24 bits, and 24 bits could just be represented as 4 chunks of 6 bits, right? 6 times 4 equals 8 times 3. So that's why we slice the characters by 3 each, and then get their binary form, and then extract them out by 6 bits, and then 6 bits means 2 to the power of the 6, which is 64. So we can actually map the numbers to the characters here, and then we could just get the base 64 encoded string. And there might be not enough data, so if some bits are not enough for 8 bits, this is 3 characters, but there might be 4 characters or something. So for that case, we need to pad the 0, and at last we need to pad for the equation mark. Yeah, for like this, this one is 24 bits, this is 24 bits, and then this is 1 bit. It's just not enough. We actually need to pad the 0 and the equation mark. So what do we do to do the opposite? Obviously, the ideal is to get 4 characters out, and then get their binary form and transform it back to this 8 bits representation, right? So the case of equation mark means this is the end. There might be some invalid input like equation mark in the middle. We need to detect that, but beyond that, we just ignore them because that means nothing. It's just a placeholder. And then when we are transforming back to the 8-bit stuff, if there are something not enough for 8 bits, we actually need to pad the 0, right? Yeah, but if there's only 0 left, meaning if there's some 0 left, it doesn't mean anything. Then actually, it would be just some paddings from the encoding, so we could just ignore this 0. But if there's 1 or something left, we need to actually padding it up. No, there won't be some cases like only something 1 left, right? Something this left. It's not, because what we're padding is 0, so it must be all be 0. If it's not, then we need to throw an error. Okay, yeah. So let's do it. So the first thing is we copy the table, the characters here. As we said, we need to transform the encoded string to some binary form, right? Let's call that a buffer. It's empty. And for each character, should you use index or just use the for off loop? I think we could just call the off. Let for const character of encoded we need to get index. We could do search, but it's not performant. We actually need to calculate the index map. I plus, and then encoded index map set base 64 I set the index to this value. So now we can have this index map and we can get the index. Index equals index map get character. And then we need to get the binary form, which is index to a string. So it might be not enough for 8 bits, so we need to pad it. Padded start 8 with 0. And then we could add to the buffer. There's a problem that if we meet the equation. So let's use a flag set is equation met. It's false, and here if character equals equation, then it's true. No, if it is equal equation, we set it to true. And if it is not equation, but if it is met, then we need to throw an error. Right? And so we make sure that only the equation are at the end. And if it is this equation equals true, you made it, and then we do nothing, so we continue. Great, now we handle the buffer, so we process it. We would slice out 8 bits at a time. So I will use the start equals 0, so while start smaller than the buffer.length, we would slice 8 bits. Okay, we first const bits 8. Okay, no, this is chunk length was 8. We move the start cursor to the next, and we get the chunk out, which is buffer slice start plus chunk length. If there's 8 bits, length equals 0. It's not 0, it should be chunk length. Then it means it's valid number, so we get the number equals parse int chunk2. Because it's bits, it will always be a number, so we get character from string, get from character code, no, and we get the character, and we get the result, right? So we use the result, and result plus equals this character. And if it is not, then meaning there's something left. But if something is left, I mean, when we're encoding it, we actually appending zeros to the end, right? Appending it, and if you are getting it, they must be all zeros, right? So if wait a minute. So if I got an 8-bit 848, this is 8. Okay, 8-bit 0, and we actually got this one 0, and this padding some 0 here. So when we are going back, we're getting this and get some 0. This 0 is added, so we could ignore them. If there's another 0, say something like this. Yeah, the 0 all must be added, not less. So we could safely check if there is only 0. So if so we could okay, parse it. So maybe num equals parse the chunk. Oh, we get it. And if num is not 0, I think we should throw an error here. If there's 1, oh, when we are getting it, we need to pad it. We pad here. We get next. Wait a minute. Wait. It's not 8 here. Actually, it should be 6. Yeah, my bad. Okay, we pad 6, and it should be enough. If there's something left, then it's wrong. So yeah, if it is 0, then we throw new error. Valid input. It's great. Then we return the results. Let's give it a try. Console log. Ooh, toString I'm defining. toString index. Ooh, yeah. Index. If an index is not there, if index equals to null, throw new error, invalid input. Ooh, no. God. If it's 0, we continue. If it's equation mark, we continue. Interesting. We handle character Q, and we got K. There's something wrong here. 0. We increment index map set the character and the index. Console log index undefined. Why we get undefined? Character is K. There should be something. Interesting. Text map set. Set A. We can console log index map get A 0, get B 1, and get Q undefined. Q's here actually. See? Huh? Always undefined. Oh shit. I got it. I got a mistake here. So we get it's still invalid input. It's console log. Okay, invalid the character in the disallowed character. Invalid equation mark. Then here should be invalid input. So error is here. console log num and chunk.length. Chunk. This is num 0. So we got 4 0. For 0, we should it's not 0. Oh god, I'm so stupid. Yeah, we got BFE.dev. Let's submit. Not good. Expect function to throw an exception. Ah, god. Why? A and 3 question mark? Ah, here. Because there is 0, but it's not enough. So this is in, yeah. When we get the buffer here, so if buffer.length bigger than 0, but buffer.length, okay, I think I need to say if it is empty. We'll just return empty. If it is not empty, then it must be more than 1 bits buffer. Buffer length should be bigger than 0, right? Bigger than the 8 bits. They will say chunk length here. So if smaller than it, then it should not be valid. Throw new error. Invalid input. Okay, it's submit. Great. It's not easy, and my code is like a little messy, but I hope it could help you. The core idea is to remove the console. Just represent the data in the 6 bits, and then extract them by 8 bits and transform them back. Great. Hope it helps. I'll post my code. Hoping it would help. See you next time. Bye bye.